Let's take a look at question number 6 from the Implicit Differentiation and Related Rates review sheet. This is our first related rates question in the batch on the worksheet. Paint spills onto a floor in a circular pattern, and they're talking about the rate at which the area of the spill is increasing. So there's a couple of clues here that lead you in the direction of the equation you should write to relate the variables together. They say it's a circular pattern, and then they're talking about the rate of change of the area of the circle. So that's going to be area formula for a circle, pi r squared. And then you are, with all related rates questions, differentiating everything with respect to t. So in the implicit differentiation problems where all the y derivatives had to be multiplied by dy dx, now every variable term's derivative has to be multiplied by d of that variable over dt. So let's start the process here. A is going to become dA dt. Pi is a constant. R is a variable, so the pi r squared will become 2 pi r, and then of course times dr dt. Now in the question, they gave you some of that information. They told you this instant the radius is 18 inches, so r can be replaced with 18. And dr dt is 2.5. But I want to point something out here, especially on a non-calculator question. 2.5 is the same as 5 halves, and if you write that as a fraction, then it's real easy to see the cancellation between the twos there. So in the end, I wind up with 18 times 5, or 90, times pi, which is answer choice D. All right, moving on. Question 7. This one's a tricky one, but they give you clues to lead you in the right direction. Number one, they're saying it's a right triangle. They tell you the base is x and the height is h. They're doing that for a reason, because you're going to need the right triangle a little bit later on. They also tell you h is constant and x changes with respect to time. They give you the angle now. There's so much information in here. Angle theta, and it's defined by tan of theta equals h over x. And which of the following best describes the relationship between, notice there's two rates of change, both with respect to time here. There's d theta dt and dx dt. That lets you know it's a related rates question. And if you take a quick glance at your answer choices, every single one of them has d theta dt equal to something times dx dt. All right, so related rates questions, it's really, anyone's guess as to what the relationship would be here if they didn't tell it to us. They gave us that tangent equation. So let's start off with this. We're going to take the derivative of the left and the right side. Remember, on the left side, your variable is theta. On the right side, h is a constant, not a variable, but x is a variable. H over x, by the way, we can think of as h times x to the negative 1. So when we differentiate this, the derivative of tangent is secant squared, but like all related rates questions, every time there's a variable, you have to multiply that derivative term by the variable's rate of change. So in this case, d theta dt. The derivative of hx to the negative 1 would be negative h times x to the negative 2, but that's just negative h over x squared, and of course times dx dt. Now this is all well and good, but none of my answer choices have a secant squared in there if I were to divide both sides by that secant squared factor. So here's where the right triangle business comes in. I have to somehow replace secant squared with some other expression in terms of h and x, because that's what's in all the answer choices. So I'm going to make my right triangle here with x as the base and h is the opposite side from theta. And I'm going to use the Pythagorean theorem to find the length of the hypotenuse. Because secant is the reciprocal of cosine, cosine is adjacent over hypotenuse. So my hypotenuse will be radical x squared plus h squared. And once again, secant is the reciprocal of cosine. So cosine's adjacent over hypotenuse, secant will be hypotenuse over adjacent. And in our right triangle, that's the radical x squared plus h squared over x. So now secant squared can be replaced, and I can put that expression in for secant. If you square it, you're going to get rid of the radical. The denominator is going to become x squared. And then I could divide both sides by that fraction or multiply by its reciprocal. I'm going to skip over some of that algebra here, but you're going to wind up with d theta dt equals negative h. The x squareds will cancel out, and you'll have that x squared plus h squared in your denominator times dx dt, and that is, of course, choice A. Okay, moving on to question 8. At time t greater than 0, you've got a cube and the edges, right? The volume of the cube is v of t. The edges are also a function of t, but they're x. Their length is given by x. And then they say the volume of the cube decreases at a rate proportional to its surface area. So there's a big, big clue right here. When you see proportional to, that means a constant times. So the wording of the question, the surface area, if the edges are x, then you would have each square face would have an area of x squared, and there's 6 of those faces, so the surface area would be 6x squared. Now back to the proportional to meaning a constant times. In the words of the question, it says its volume decreases at a rate proportional to its surface area. So the rate of change is the thing that's a constant times the surface area. So the rate of the volume is dv dt. Proportional to is a constant times, and the surface area we know is going to be 6x squared. Now, I don't have a 6 in any of my answer choices here, but that constant, the proportional to constant that I don't know what its value is, when you multiply it by 6, you're going to get one of those coefficients up there. The real key over here is that it's x squared. So choice A is the only match for this question. It's the only one that has a dv dt equal to some constant times an x squared. So choice A. This one actually turns out to be a pretty quick question if you know what proportional to means and you know it has to be in terms of x squared. All right, moving on to question 9. Here, another related rates. But this is in 2 parts, and I wrote out the first clue there. You get a sphere saying that the area of a circular cross-section through the sphere's center. That's called a great circle. When they tell you that, they're telling you a circle that has a radius that's equal to the radius of the sphere. That's really the big takeaway here. So the strategy for this is to use the area of a circle to find dr dt, and then go and do a related rates question with the volume formula and substitute in the dr dt. So the area of a circle is pi r squared. We're going to take the derivative of everything with respect to time to get that, just like in the earlier question. And when I do my substitutions here, I know what r is at this moment. It's 4 centimeters. I know dA dt is increasing, so it's positive, and that's 2 square centimeters. And when I solve for dr dt, I get 1 over 4 pi. So that's my dr dt. Now I can go and answer the actual question for the rate of change in the sphere's volume. The volume of a sphere is that formula. They gave it to you. Take the derivative with respect to time, and we wind up with this. And again, this is at the same instant when the radius is 4, so I can do my substitutions. The 4 pi's are going to cancel out very nicely, and I simply wind up with dv dt equals 16, which is a match to answer choice B. Answer choice B. All right, we'll continue with the next questions in the next video.